So in this video, we are going to see problems from exercise 8.3. There are three problems: problem number 3, problem number 4, problem number 5. All of these three are quite similar to each other, so we'll see them one after the other. Let's start with problem number 3. It reads, if tan 2a is equal to cot a minus 18, where 2a is an acute angle, find the value of a. Okay, so this is the equation that we need to focus on. Tan of 2a is equal to cot of a minus 18. Now we all know that tan and cot are two trigonometric ratios which are related to each other by complementary angle property. And what is that property? So let's note it down. We know that tan and cot, these are two trigonometric ratios which are related to each other by the complementary angle property. 90 minus theta, tan of 90 minus theta is equal to cot of theta, where theta is some angle. Okay, so similarly this expression, let me use a highlighter, this expression is related to each other. Here we have tan, here we have cot, and so their angles will have this complementary angle relationship. Okay, so that is the property that we are going to use to find the value of a. So let's start with LHS. So given, let me write here, given left hand side of the equation is equal to tan of 2a. Okay, now tan of 2a can be converted into cot, and you have to change this to 90 minus whatever is the angle, 90 minus 2a. Okay, and now once again, what is RHS? Given RHS is equal to cot of this thing, cot of a minus 18. So RHS is equal to cot of a minus 18. Yes, so cot of a minus 18. Okay, so now we have left hand side in the terms of cot, and we have right hand side also in terms of cot. So let's put them one beside the other. So left hand side, okay, is equal to right hand side. Okay, that is by the given equation. Now what is left hand side? Left hand side is cot of 90 minus 2a, and right hand side is equal to cot of a minus 18. Okay, so now we have both the sides of equation where cot and cot are equal to each other, so which means the values of this angle should also be equal to each other. Okay, for example, uh, yes, for example, we will have cot of 30 as equal to cot of 30 itself, right? So this 30 and this 30 should be same to each other. Similarly, if we have cot of 72, that will be equal to cot of 72 itself. So this 72 and 72 will be same because this is same. This trigonometric ratio is same. This trigonometric ratio is same. Similarly, if you focus on this equation that we have now here, so this is cot here, this is cot here. So since cot and cot are same, it's the same trigonometric ratio, their angles should also be same. So 90 minus 2a and a minus 18 should be same. Okay, so uh, so we can say, I'm going to write here, we can say that 90 minus 2a is equal to a minus 18. So thus we get an equation in the unknown variable a, and now we are going to rearrange. So I'm going to say 90 plus 18 is equal to a plus 2a. Okay, and therefore I'm going to get 8 and 108 as equal to 3a, and therefore a will be equal to 108 divided by 3, that is equal to 3 3s are 9 and 3 6 are 18. So a is equal to 36, or you can say 36 degree. So the value of a, which is I think what we have to find out. Let's go back to the question. Find the value of a. So a is equal to 36 degree. Let me make a note of that. A is equal to 36 or 36 degree. Be careful what the question is asked. Sometimes they might ask you to find the value of 2a or a minus 18. So in that case, your answer will have to do one more additional step and find the exact expression of a that the question is demanding. Here the question demands just the value of a, so we have found it that to be 36 degree. Okay, so again in the similar fashion we have the next question which we are going to see. Okay, let's pull this down. Yes. So the question reads, okay, let me try to erase this. Now the question reads, if tan A is equal to cot B, prove that A plus B is equal to 90 degree. Okay, so once again, let's clear out this. We will just need this one. Yes. Okay. Now, once again, what is the scenario that is given in the question? We have tan and cot on two sides of the equation, and we know that tan and cot are these two trigonometric ratios which are related to each other by complementary angle property. So if we have tan here and if we have cot here, we should use this complementary angle property and try to solve the given problem. Now they say that tan A is equal to cot B. So again, I'm going to take the left hand side first. Left hand side of the equation is equal to tan A, but tan A can be written into cot of 90 minus A. Okay, and now we have RHS. So I'm going to write RHS here. RHS is equal to cot of B. Okay, but left hand side of the equation is equal to right hand side of the equation. Okay, so cot of 90 minus A, which is my RHS, will be equal to cot of B. Okay, now once again we have cot on both the sides of the equation, so their angles have to be equal to each other. This is the important point. The angles have to be equal to each other. So thus we can say that 90 minus A is equal to B. And now if we rearrange the equation, if we take this minus A on the right hand side of the equation, we get therefore 90 as equal to A plus B, and which is exactly what the question asks. The question says that if tan A is equal to cot B, then prove that A plus B is equal to 90 degree, and that is exactly what we have proved. So this is also done. Let me mark it. Okay. So problem number 4 is also done. Now let's come to the final problem, which is problem number 5. It reads, if sec 4a is equal to cosec a minus 20, where 4a is an acute angle, find the value of a. This is exactly similar to question number 3. Okay, here we had tan and cot, here we have sec and cosec. So once again, let me first erase this so that we get some space. Okay. So once again, we have we have sec and cosec on the two sides of equation. We know this is a hint. If we have sec and cosec on two sides of equations, we have a hint. The hint is that sec and cosec are related to each other using the complementary angle property. What is that property? Sec of theta is equal to cosec of 90 minus theta. This is how they are related. Or vice versa, even you can say cosec of theta is equal to sec of 90 minus theta. Okay, doesn't matter. The point is that sec and cosec are related to each other through complementary angle. These two are complementary angles. Okay, why are they called complementary angles? A quick revision, because the summation of these angles is equal to 90 degree. Whenever summation of any two angles is equal to 90 degree, those two angles are called as complementary angles. Okay. So now, once again, we begin with LHS. So the left hand side of the equation is equal to sec of 4a, and sec of 4a can be written as cosec of 90 minus 4a. Okay, and the reason behind this is, what is the reason? Complementary angles property, okay, of trigonometric ratios, okay, of trigonometric ratios. Yes. So yes, so this is my left hand side, cosec of 90 minus 4a. Now what is my RHS? RHS is also in terms of cosec, let's write it down. RHS is also equal to cosec of a minus 20. So here it goes, cosec of a minus 20. Okay. Now we have left hand side in terms of cosec, we have right hand side in terms of cosec. So let's bring them opposite to each other. So left hand side is equal to right hand side. Okay, but what is my left hand side? Okay, let's get rid of this. Now my left hand side is cosec of 90 minus 4a, and my right hand side of the equation is cosec of a minus 20. Okay, now we have cosec here and we have cosec here. So both the sides of the equation we have same trigonometric ratio, which means that these two angles have to be equal to each other. Okay, thus we can say that the angles should be equal to each other. So 90 minus 4a should be equal to a minus 20. Okay, and now thus we have an equation in an one unknown variable, which is a. So we can very easily solve the equation. We take 4a to the right hand side of the equation. So let's do it. Therefore 90 and 20 will come to the left hand side, is equal to a plus 4a, and 90 plus 20 is 110, which is equal to now 5a. Okay, and therefore we have a as equal to 110 divided by 5, that is equal to 5 to the 10, and again 5 to the 10. So a is equal to 20, and that is exactly what the question has asked us to find. Okay, given this, if this is the scenario, then find the value of a. So we have found the value of a as equal to 22, very much similar to 22 degree, very much similar to question number 1 where a was 36 degree. So thus, using the complementary angle property for trigonometric ratios, we have solved 3, 4, 5 from exercise 8.3.